Good day everyone. This time we will discuss on functions and relations. For our objective, we have to decide whether a relation is a function and use function notation. For the definition, relation. When you say relation, it is any set of ordered pairs. And a relation is a rule that relates values from a set of values, which called the domain, to the second set of values, which is also called the range. Relation has the elements of the domain can be imagined as input to a machine that applies a rule to these inputs to generate one or more output. A relation is also a set of ordered pairs, x and y. Function. Function is a type of relation where there is exactly one output for every input. For every x, there is exactly one y. In another way, a function is a relation where each element in the domain is related to only one value in the range by some rule. The elements of the domain can be imagined as input to a machine that applies a rule so that each input corresponds to only one output. Again, a function is a set of ordered pairs, x, y, such that no two ordered pairs have the same x value but different y value. For example, the given for x are number 1 and 2. For y, we have 6 and 7. 1 can be paired by 6, 1 can also be paired by 7, and 2 can be also be paired by 7. In another way, 1 can be paired by 6, 2 can be paired by 6. So in this given, the first pair for 1 and 6, 1 and 7, 2 and 6 is not a function. While for the second example, which 1 as x and y as 6, 2 as x and y as 6, the given are example of a function. We have y is equal to 2x. So in a chart and mapping, we have for the value of x, we have negative 2, negative 1, 0, 1, and 2. So the value of y are negative 4 for negative 2 of x, negative 2 for negative 1 of x, 0 for 0, 1 for 2, 2 for 4. That is by substituting the value of x in the equation of y. Through mapping, we have the input and output. We have negative 2 as an input, negative 1, 0, 1, and 2. For the output, we have negative 4, negative 2, 0, 2, and 4. So in this case, the equation y is equal to 2x is an example of a function since it is through mapping that we have one-on-one function. So we have here another example. You determine whether the equation is a function. Y is equal to the absolute value of x and x is equal to the absolute value of y. Again, we have the set of values of x. By substituting y is equal to the absolute value of x. Negative 2 is 2. For negative 1, that is 1. For 0, 0. For 1, 1. For 2, 2. So the input are negative 2, negative 1, 0, and 1. For the output, 0, 1, and 2. So negative 2 is for 2, negative 1 is for 1, 0 is for 0, 1 is 1, 2, and 2. So the value for the first equation, y is equal to the absolute value of x, is an example of function. While in the other hand, x is equal to the absolute value of y. Again, we will be using y is equal to negative 2, negative 1, 0, 1, and 2. 2, 1, 0, 1, and 2 for the value of x. For the input, we have 0, 1, and 2. For the output, we have negative 2, negative 1, 0, 1, and 2. Let us see through mapping. 0 is for 0, 1 is for negative 1, 1 is for 1, 2 is for negative 2, 2 is 2. So the function or x is equal to the absolute value of y is an example of not a function. Next, we can also test whether the graph is a function or not through vertical line tests. We have here through vertical line test, the example number 1 is a function. Let us see. For number 2, still it is a function. For 3, it is not a function. For number 4, it is a function. 5, not a function. 6, function. Not a function for number 7. Sample 8, it is not a function. It only means that we can determine the graph if it is a function when it passes once in a graph in a vertical line test using the vertical line tests. In a graph, again, in a graph, when the vertical line test passes the graph only once, then that graph is a function. Okay, we have here another example. You tell whether the relation below is a function. Number 1. Input is 0, 1, 2, 3. The output is 5. The answer is function. Number 2. The value of x is negative 3 all the way. The value of y is negative 1, 0, 1, and 2. So, number 2 is not a function. Number 3, by vertical line tests, it only proves that it is not a function since it would touches 3 times on a vertical line tests. For number 4, again, last, the example is not a function. You try to look at the input. Negative 2 has the output of 3 and 4, while negative 1 has the output of 5, 0 has the output of 6. Remember,